7th grade lesson 3.6 is applying rational number operations. It is puzzles. Think of them like puzzles, word problems that apply your skills for fraction operations, adding and subtracting fractions, multiplying, dividing fractions, decimal operations, adding or subtracting decimals, multiplying decimals, or dividing decimals. So in your first page of your notes, I have included all the steps for those. However, since in the previous lessons you all practiced those skills, I am comfortable with you using calculators for this. You'll have to make some arrangements for the fractions, turning them into decimals and things like that if you choose to use a calculator. But more than anything, it is practicing and solving through puzzles using those word problems. Remember our word problem steps. Read it first, underline what you're asked to do, circle the information they gave you, draw it to help your brain figure out what's going on, ponder a little bit because some of this will take some more than one step, and then solve, slowly but surely solve it. What pieces of information do we need, etc., etc. So let's go ahead and dig into this and look at what puzzles they're going to throw our way. The first problem they throw our way is about John, and he's hanging a picture on the wall. He wants it to be centered horizontally on the wall, not more to one side or the other, because that would drive you crazy if it's all off center, right? The picture is 32.5 inches long, and the wall is 120 3/4 inches long. How far from each edge of the wall should he place the picture? I have actually been in this circumstance before. I wanted it centered on the wall. I didn't want it off to one side because maybe it wouldn't bother me so much, but I knew it would bother my husband a lot. So let's go ahead and take our steps. We read the question. Let's go ahead and underline what they're asking us. How far from each edge of the wall should he place the picture is what we want to know. The information they gave us is we want it centered horizontally on the wall. The picture itself is 32.5 inches long, and the whole wall is 120 3/4 inches long. Let's draw that picture. So I'm going to draw a wall, and actually the book had a nice picture in there, much better drawn than what mine would be. But here's my wall, 120 3/4 inches across. Then I have a picture on the wall, 32.5 inches long. And I want to know if I want this to be equal distance here, here, and here. I want to know what kind of length I need to have on there. What is the measure of this section? So here's my picture, and here's where I'm going to ponder, what would it be helpful to know? If I want to know how much is here and here, it probably would be helpful to take this amount and pull this out of there so I know how much total that is together. That would be helpful. So let's do that. I'm going to take 120 3/4 and subtract from it the amount of the picture, 32.5. All right, if Mrs. Sanchez is allowing me to use a calculator, my calculator doesn't have fractions on it, but I do know that 3/4 in money is 75 cents. So I'm going to put 120.75, and I know that half a dollar is 50 cents, or the same as 5 dimes. And then I'm going to go ahead and subtract that on my calculator. And that gives me 88.25 when I did that on my calculator. Remember, 25 cents is 1/4. So if you really wanted it as the fraction still, there it is. Okay. So I know, I'll put or, I know that without that there, I have a measurement of 88.25 inches, these together. And I want them to be equal, exactly the same amount. So I want 88.25 in 2 equal parts. What calculation gets me 2 equal parts? Yeah, you got it, division. So I'm going to take 88.25 and divide it into 2 equal parts. I'll calculate on my calculator. And that gives me 44.125. I'm going to put that back into fraction form. That is 125 in the thousandths place. And if I reduce that, 125 does divide into 1,000. It divides into this once and into 1,000 8 times. So my answer is 44 and 1/8. So what I'll want is for each of these sections to be 44 and 1/8 inches wide. Nice and equal. I like it like that. And then my picture at 32.5, beautiful picture. And then my wall there, this plus this plus this will equal the entirety of the wall. So that took 2 things to ponder. It took 2 calculations, and you're going to find that with a lot of this stuff, plus reasoning out what was my answer representing, in case there's some funky thing that shows up like it does in the next one. Let's see. All right, here we have Alana making some blueberry muffins. Here's the recipe for that, in case you wondered. She needs 1 1/4 cups of all-purpose flour. Let's read what we've got to do here. Alana uses 1 1/4 cup of flour for each batch of blueberry muffins that she makes. Yeah, we saw that. She has a 5-pound bag of flour that costs $4.49, and it contains 76 1/4 cup servings. How many batches can Alana make if she uses all the flour? And how much does the flour for 1 batch cost? That's a lot to digest. Let's underline what they're asking me to do. They asked me 2 questions, actually. How many batches can she make if she uses all the flour? And how much does the flour for 1 batch cost? I'm going to put these questions off to the side so that I remember to answer both. Because sometimes I get all the way done and think, oh, yay, I'm done. And then I realize, oh, they asked me 2 questions. Whoopsie, whoopsie. So how many batches? Number of batches for the pound of bag was the first question. And how much was the cost of flour for 1 batch? So she must be able to make several batches. We don't know how many yet, but how much was the flour cost for 1 batch? All right, 2 questions. Let's go back and circle information that we were given. I do know that 1 batch takes 1 1/4 cup of flour. I do know she has a 5-pound bag. What that is in cups, I'm not sure. I do know that 5-pound bag costs $4.49. Oh, here we go. And it contains 76, they tried to hide that in words, 1/4 cup servings. 76 1/4 cup servings. That was helpful. That was the question I was asking before. Let's draw the picture. I'm going to draw a 5-pound bag of flour. There it is. And I wondered, as I was going along, you heard me wonder, 5-pound bags, I'm dealing with cups of flour. I don't know what 5 pounds is in cups of flour, but then they told me 76 1/4 cup servings. So this is 76 1/4 cup servings. 76 times 1/4 cup servings will give me how many cups are in there. And then they're asking me, I'm going to take 1 1/4 cup out for each batch. How many times can I do that before I run out? Couple of calculations needing to go on here. The first one we almost kind of mentioned here. I have 76 1/4 cup pieces. So I have 1/4 cup plus 1/4 cup plus 1/4 cup plus 1/4 cup 76 times. Well, let's find out how many cups that whole thing is. That's how much this represents as a 5-pound bag. So let's do that calculation and find out how many cups that gives us. We're doing 76 times 1/4. I can put that over 1. I can cross reduce. I don't know if 4 goes into 76 evenly. Let me experiment and see. It goes once there and 36. Yes, it sure does. I mean, I could have put that on my calculator, but I figured that wouldn't be too difficult. 19 times 1 is 19, and 1 times 1 is 1. So there are 19 cups in the bag. Now I know that this bag contains 19 cups of flour in it. Each batch that she's making is 1¼ cup. So I'm doing 19 cups divided into 1¼ cup until I run out. 19 divided by 1¼ I'm repeatedly taking out 1¼ out. Let's use that trick so you could use your calculator. You know that 1/4 is 25 cents, so that is 1¼ or 1.25. 19 divided by 1.25. Run it on your calculator. And you've got 15.2 batches. These are representing how many batches we can make. 15 whole batches and 0.2 of another one. Are you doing 2/10 of a batch? I mean, remember, this batch needed an egg. Like, how are you going to split an egg into 0.2? A third a cup of milk, now I need 0.2 of that. A cup of berries, now I need 0.2 of that. You're not getting a full batch. And they were asking, how many batches can she make? So we're just going to have to drop that 0.2 off there. She's going to have a little flour left over. We can't use that for another batch. How many full batches can she make? 15. So that answered this question. 15 batches. With a tiny, tiny, tiny bit left over, not enough for another batch. The next question they asked me is how much did it cost for one batch? Well, I made 15 batches with the $4.49 that I spent. So let's take that $4.49 that I spent for 15 batches and divide it up to see how much one batch cost. And I'll calculate that on my calculator. I get a big old answer of 0.299333 blah blah blah. But we're talking money, right? We don't have a coin past this, so let's just round it to the hundredths place, the pennies place. That's an up number, so we'll just make that go up from 29 to 30. It costs us 30 cents per batch for the flour. And there's our two answers. So things to watch out for. First, think things through. What piece of information would help you get to the next step? And then what piece of information helps you get to that next step? Also think things through too. What are each of your answers representing before you move on? We didn't need to calculate that 0.2 in there because we were asking for how many full batches. So it's important to keep in mind as you go through these puzzles that you know what's happening, you know what your answers are representing, what's logical, and what steps do you need to take next. Think of it like cleaning a room. You don't just suddenly clean it all at once. You do one thing at a time. Well, I think I'll go for this corner first and then that corner next. What piece of information will help you move on to the next step? And that's what we did here. We needed to know what that was in cups. Then we needed to know, split that into the 1 1/4 cups. How many batches is that? We had to be logical about it. Then if we get 15 batches and it's $4.49 for the whole bag, how much does each batch cost in flour? One piece at a time. Let your brain think it through. All right, let's look at one more. The depth of Golden Trout Lake has been decreasing in recent years. 2 years ago, the depth of the lake was 186.73 meters. Since then, the depth has been changed at an average rate of negative 1.34% per year. What is the depth of the lake today? Okay, let's underline the question. What is the depth of the lake today? Let's go back and circle information. They said 2 years ago. That's going to be an important piece of information, I believe. It was 186.73 meters. Since then, the depth has been changing at a rate of negative 1.34% per year. And what is the depth of that lake today? All right, let's draw the picture. I have this lake, water. And 2 years ago, it was at 186.73 meters. But it has gone down each year 1 3/4% of that, percent of original. And that was after 1 year, and then it did that in 2 years. So we want to know the depth of the lake today. All right. So Let's start by making this calculator friendly. This is 1 3/4, also known as 1.75%. Dusting off a few cobwebs here, percent of number, to make a percent into a decimal, we divide by 100. So we're basically just moving this decimal 2 times over. So 1 and then put a 0 there. 2.0175 is the number we'll use to represent that percent. After 1 year, it was 186.73%. After 1 year, it shrunk by 0.0175 of that, of being a multiply word. So to find out what it was after 1 year, we're going to multiply this times this, so that we can know the percent, what we were left with. 186.73 times 0.0175. Calculator. And the answer you get is 3.267775. Let's round that to the hundredths place. 3.27. That's how much it went down by. Remember, these were negatives going down. It went down by this much. So let's go ahead and find out what that landed us at right here for the first year. So we'll do 186.73 minus the amount it lost. And that gave me 183.46. From there, the next year, it lost another 1 3/4% or 0.0175 amount. It's not the same calculation as this one, though, is it? Because it's that much, 1.75% of this amount this time. So now let's go ahead and do the new amount times 0.175. How much did that go down by? Calculate it. And the answer I get is 3.21055. I'm going to round that to the hundredths place and just call it 3.21. That's how much it went down by from here. So I'll now do my subtraction. 183.46 was where it was after 1 year. The second year took another 3.21 out of there, and that left me with 180.25 feet. Sorry, that's meters. Meters. Fixie. Meters. So it took pieces. It took this drawing. I had to dust off my cobwebs on percents. Percent is out of 100. 1.75 out of every 100. To calculate, I just needed to move my decimal over and use that twice, 2 times. 100, 0, 0. And then find 186.73. I needed 1.75% of that. Got that. That's how much meters came off of there. That gave me that. Then I had to do it one more time because it was 2 years. And then I ended up with that. This was the amount it was at a year ago, actually. That gave me negative 3.21 meters. And there's my answer. That is the final answer. It took a lot of steps, but if you slowly work through your steps and you draw the picture, it helps you figure out what to do. Sometimes these sorts of problems are good to do with a study buddy too, to reason these out.